So, okay, good afternoon. So, we will continue with chapter number 5 on communication receiver. Okay, last week we have completed chapter number 4. We have seen about the communication transmitters. Okay, so the circuit that involve in transmitting your modulating or modulated signal. And this week we will see a very short chapter, okay, on the communication receivers. Okay, so what are the elements involved in receiving the modulated message in the other end? Okay, so we know the purpose of communication is to transmit a message from one end to another end. Okay, so when we are sending in wireless, so we need to use transmitter and also receiver. Okay, so that's the function of communication, and receivers are playing very vital role in the communication, because when you transmit a message but you don't have a receiving receiver to receive in the receiving end, then it will be troublesome for you, because the message will not be delivered, and it will defeat the purpose of a communication. Okay, so today we will be looking at these 5 subtopics. Okay, so the outline we will be seeing a basics of super heterodyne receiver. Okay, so block diagram of a super heterodyne receiver. Okay, so working of super heterodyne receiver, and concept of gang tuning capacitor in a super heterodyne receiver. So image frequency in super heterodyne receiver. Okay, so maybe the name is a bit uh, look complicated, but it's actually is a very fine element of receiver. Okay, so we will go straight to the first subtopic. So basic of super heterodyne receiver. Okay, so at high frequency, processing cost of circuit is high. So we should do signal processing at a low frequency. Okay, so when we are transmitting or receiving a message, so we involve a lot of circuit. Okay, so circuit, and we also saw in the previous chapters. So signal can be transmitted in high frequency as well as low frequency. So the first statement says, so if let's say you want to send a message or a signal at the high frequency, so the processing cost of the circuit is very high. So meaning the cost to develop the circuit to deal with high frequency is very high. So they are suggesting we should do signal processing at low frequency. So signal processing is like outlier. You want to remove outliers, so you want to do denoising. So usually when we are dealing with softwares, so if you are familiar with OBS, so we can see a lot of filters inside to filter. So only one this certain frequency you want to remove noise. So all that are called as signal processing. Okay, so if you want to do a signal processing, so they suggest you do at the low frequency, because the processing cost is low. So that's what they suggest in the first statement. Okay, so in the second statement, at low frequency, transmission cost of signal is high, because you are dealing with low bandwidth. So signal transmission should be done at high frequency. So it's opposite to the first statement. So meaning, after you conclude this, so we can come to this conclusion. So you use a super heterodyne receiver. So it's a type of receiver used in communication. Okay, so we take care of this above point. So signal transmission you do at high frequency, because the cost will be lower. But when you are processing a signal, you do at the low frequency, because the cost will be lower. So meaning you need to have two separate process. So first, before you transmitting, you need to process the signal first. So signal processing, you make it go to a lower frequency you process, you do whatever touch up everything. So you already improve the signal. Then have you must have a step up frequencies step up process, where from low frequency you make it high frequency, but before you transmit it. Okay, so it will have two separate processes that we need to combine. So super heterodyne receiver will have these two process inside. Okay, so we see super heterodyne receiver. So the term heterodyning. Okay, so heterodyning. So the process of mixing two signal having different frequency to produce a new frequency is called heterodyning. So meaning you have two signal similar like how we have seen in the modulating. So you have a carrier signal and also modulating signal, message signal. So you combine together. So heterodyning is some sort like that. Okay, so we are mixing two signal with different frequency. So meaning signal one, the frequency is f1. Signal 2 is f2. So you have two different frequency. So you're mixing it together using a mixer to produce a new frequency. Uh, so this process we call it as a heterodyning. Okay, so the super heterodyne receiver converts every selected RF signal to a fixed lower frequency called the intermediate frequency. So you combine first. You combine using a mixer. You combine and you combine and convert it into a frequency. Okay, so you combine to a lower frequency, and this lower frequency we call it as a intermediate frequency, or we use the short form IF. Okay, so that's the process. Okay, so why we want to convert it into low frequency? So as we saw in the previous, so at low frequency, so the transmission cost will be I, and okay, sorry, at low frequency, so we should do the signal processing. Okay, so once you do the signal processing, then you can step up and send to in the higher frequency. Okay, so the block diagram of super heterodyne receiver. So we have a receiving antenna. Okay, so all this process will be in the receiving end. So last week we saw the transmitting end. Okay, so let's say you want to send a message from Kanga to Kuala Lumpur. So you have a transmitting antenna at Kanga, receiving antenna at Kia. Okay, so this process are happening in the receiving end. So yeah, first you are having a receiving antenna. So you receive whatever message that is modulated and sent. You receive it. You send to a radio frequency amplifier. Then you have a mixer, or we call it as a first detector, and you have a local oscillator. So local oscillator we know from the modulating signal modulation. We know local oscillator, so it will generate a fixed frequency signal. So earlier we saw the point. So at mixer, so you need to mix the signal coming from RF amplifier and also local oscillator. You mix together, then you can process it further. Okay, so IF amplifier is intermediate frequency amplifier. Then you have other detectors and also amplifiers before you can hear the message that is delivered. Okay, so that this is the block diagram of a super heterodyne receiver. Okay, so we will see one by one. Okay, so the first part it will be receiving antenna. So the receiving antenna, the function is to receive whatever modulated signal that is sent from the other end. So you receive, then you pass it to RF amplifier. Okay, RF amplifier is radio frequency amplifier, because when you are dealing with different signals, so you have a very big bandwidth. So you can have a a lower frequency signal, you can have a higher frequency signal. So all these are considered as a radio frequency. Okay, so once it passed to the radio frequency amplifier, uh, so here the signal that is going out is having a frequency of RF, FRF. So we call it as a FRF. So it will be sent to the mixer. Okay, mixer, or this will consider as a first detector. So the detector means, so it is detecting the frequency sent. Okay, so we are receiving this. Uh, then we know local oscillator. So the signal that is generated by the local oscillator is having a frequency of FLO. So frequency, so LO is local oscillator. So not low, so it's not like low value. So F LO is local oscillator. Okay. So once you receive this, so here you are receiving FRF, and from here you are receiving FLO. Uh, so at the mixer, you will get this particular. Uh, so in mixer, you usually will have two process. One process we call it as a addition, and one more we call it as a subtraction. Okay. So for addition, you just add up FRF plus FLO. So that is we call it as addition, and subtraction FRF minus FLO. Okay, so that is a subtraction. So both process are happening in the mixer. Okay, so at this process. Okay, so the output is these two. Okay. Okay, so once you already have these two output from the mixer, then you will pass it to IF amplifier or intermediate frequency amplifier. Uh, because once you do the heterodyne process, so you want to shift it to intermediate frequency. So if you see from the previous slide, so the super heterodyne convert the selected RF signal to a fixed lower frequency, which is intermediate frequency. So this is happening in the IF amplifier. So I go back. Okay, so it is happening in the IF amplifier. So first you generating this, and in the IF amplifier you are reducing the frequency to the intermediate frequency for processing. Okay, so once you finish this, uh, so the output of this is FIF. Okay, so IF is intermediate frequency. So frequency of intermediate frequency. So it will be passed to the second detector. Okay, and so from output of the second detector is FM, or the message that is supposed to send, or this is the modulating frequency FM. Okay, so it will be the output because we are already receiving the end user. Okay, so once it converted to the message, so it will be power amplified. So it will power amplify and also send to the speaker for the person to receive. Okay, so even now, so we are sending things wirelessly. So I'm talking from my end. So let's say I'm using a transmitter, so transmitting this message to you. So maybe you are in the hostel or you are in the house. So you will have a antenna at your part. So then you'll have RF amplifier. So it will generate a FRF. Then you'll have a local oscillator to generate FLO. So it will be mixed together. So the output of this will generate this. It will be passed to the IF amplifier to generate this FIF. It will be sent to second detector. So output of second detector is the message FM. It will be passed to the power amplifier. So the power amplifier is in your phone or in your laptop. So it will amplify the message so that it will come to the uh, suitable gain for you to hear using your ears. So this will, it might be your phone speaker or your laptop speaker. So it must be power amplified in order for you to listen. So if you don't have the power amplification, so you cannot increase the gain. So if let's say, so the output of this detector is only 1 dB. So 1 dB means is like very it's like very soft for you, for human being to hear. So when you are using power amplifier, 1 dB of the input here, so it will be power amplified maybe to 50 dB. 50 dB we can hear naturally. Okay, so that's the function of power amplifier. Okay, so here we have a condition. Okay, so all these processes are the same. Okay, all the processes are the same. So earlier we have seen uh, you will receive uh, FRF from this part. Okay, from this part, and from here you will have FLO. So FLO, so usually will have two functions, two statements. So one is addition. So FRF plus uh, FIF. So IF is coming from, is supposed to be coming from the IF amplifier, but here if you want to generate FLO, so you need to, you will be having two output. One, it must be plus, or and one more is it must be minus. So usually we should not keep FLO less than FRF. So meaning, so the FLO, so let's say this is only 1 kilohertz, but here is 10 kilohertz. So we shouldn't accept that because FLO 1, this is 10. So it is lower than FRF. So we don't prefer FLO equals to FRF minus FIF. So usually we won't take this. Okay, so we will eliminate this signal. This statement, we only will consider the addition. So that's why we are only taking the addition for our analysis. Is usually so if let's say FLO is I, so it's 20. FRF is 10, so it can be accepted. Okay, so only in this condition, so we won't take the second part. Okay, so here we, okay, so you have a FLO here and FRF. So we can have two condition. Okay, so here, so FLO is FRF plus FIF, and here we are mixing with FRF. So here you, for addition, you have two FRF, FRF and FRF. You plus, it will become two FRF plus IF. Okay, so this is for the addition. So for a difference, so different FRF minus FRF plus FIF. So FRF minus FRF, so it will become 0. So for difference or the subtraction, you will only have FIF. Okay, so this is by adding or subtracting these two, because this is output of the mixer. Okay. Okay, then you'll have FIF here, so output of the IF amplifier, then FM, and you'll have a amplified FM. Okay, at this point. Okay, so this is what I was like telling. So here FRF, FRF, FRF. So you have two. So first part. Okay, So let's say this part we consider as, so to avoid confusion with this, so let's say this part we consider as FRF1. Okay, so we replace this with this, and FLO equals to FRF plus FIF. Okay, so for this case, so for addition, so you are taking this FRF plus FIF here plus with FRF1. Okay, that is addition. Okay, and for subtraction, FRF plus FIF, okay, here minus FRF1. Okay, FRF1. So that is subtraction. Okay, so actually FRF1 and FRF is the same value. So you can add these two. So you can get 2 FRF plus FIF. So that is for addition. So here FRF minus FRF1. So same value. So it will cancel each other. So only remaining is FIF. So for difference or subtraction. Okay, so that is how they calculate. Okay, so usually we will use these range tuning capacitors, okay, in order to tune. Okay, so we will tune. Okay, so like in the um, car nowadays our radio in the car, we will have digitalized. Okay, it will automatically find the frequency. Those time we have a tuner, so usually we will tune to make it into the correct frequency. So usually this range finding tuning will be used to find the correct frequency for us to receive. Okay, so we will use this range finding tuning, okay, to receive whatever frequency that we want to send. Okay. Okay, so this is the same thing. Okay, so just open first everything. Okay, so again I just want to repeat. So our antenna, receiving antenna will receive. Okay, receive. So radio frequency amplifier will receive from the antenna. It will give us FRF here. So it will be sent to the mixer, and we will have a local oscillator to generate a frequency uh, for us to mix together. Okay, so FLO is FRF plus FIF. This is the formula, standard formula. So we will add and also minus subtract the values. So in order to form two output. Okay, so FRF for, let's say for addition, FRF plus FRF plus FIF. Okay, in the mixer. So FRF plus FRF will become 2 FRF and plus FIF. So that's the addition. So FRF minus FRF plus FIF. So FRF minus FRF. So it will become 0. So remaining for subtraction will have only FIF. Okay, so these two will be passed to the IF amplifier and also to the uh, next processes. Okay. Okay, so we can see, so all this are happening at the same okay, so let's say because earlier we saw this condition. If the input here is FRF, then we will get this equation. So what will happen if in the beginning we have a different frequency? So let's say here instead of FRF, we have FRF plus 2 FIF. Okay, so here FLO is FRF plus FIF. So you need to plus these two together. Okay, plus these two together. Okay, for addition, we will get so because here FRF plus FRF, so you have 2 FRF. So FIF, 2 FIF plus FIF, so you'll get 3 FIF. So this is for the equation for addition. So you'll get from the mixer. Okay, for differences, for subtraction, so we can see some important changes here. So here, let's say you have FRF plus 2 FIF minus FRF plus FIF. Okay, so you have these two process. So you will get FRF minus FRF, it will become 0. So 2 FIF, so this plus will become minus. So 2 FIF minus FIF. So you will still get FIF. So similar like this. So even though the addition part, it is changing, but for subtraction part, it will be the same. Okay, so that's why. So we try to use this mixer to reduce the uh, heterodyne heterodyne process to the low frequency. Okay, using these differences. Okay, a remark here. So even we receive a different signal as receiver, we have extracted the same signal FIF at the output of the mixer. That received signal is an image signal, F image equals to 2RF plus 2FIF. Because we can see, even though we give a different image frequency, so let's say to FRF plus 2FIF, okay, so you are giving here, we still get the same output of FIF for difference. So that's the advantage of heterodyne receiver. Okay, so this is some insight for you what will happen in the receiving end. So usually we will use this heterodyne receiver because heterodyne receiver will help you to save money actually. Okay, if you want to say in our word, it is actually saving money. Okay, as we saw in the first few slides, so the cost of the circuit will be very high, and another part, the cost of the transmission will be very high. So when you are dealing with a lot of application and a lot of end user, so end up you need to pay more than what you are getting. So that's why engineers usually will come with a solution, and one of the solution to reduce the cost is super heterodyne receiver. Okay, so in future, if you become engineer, a network engineer or communication engineer, so you can consider so how to reduce the cost, okay, of our transmission and also the processing. Okay, so that's why nowadays most of the processes are done in the high-end PC, and they just send it out uh, in the low cost transmission. Okay, so in order to reduce further the cost. Okay, so with this we conclude chapter 5. So it's a very short chapter. So the summary that we have seen today, chapter 5, communication receivers. So we have studied about the basics of super heterodyne receiver. Here we have seen the block diagram of a super heterodyne receiver. So various elements that involve. So we saw the mixer, we saw the RF amplifier, we saw the IF amplifier, we saw the oscillators. So we saw the power amplifier. So all these are component involved in the block diagram. Then we also saw how the super heterodyne receiver works. Okay, so the principle of addition and also subtraction. And we saw the function of a range tuning capacitor, okay, in super heterodyne receiver. So range tuning capacitor is for you to tune to the correct frequency for you to operate. Okay, so it can be low frequency, it can be high frequency, or it also can be an intermediate frequency. So you need to have a capacitor to tune. Okay, so you need to tune the range. Okay, so at the end, so image frequency in the super heterodyne receiver. So even though you give a different kind of signal as an input, uh, uh, the output of subtraction will still be the same. Okay, so that is what we studied today. So any question? Okay, any questions that we you want to ask? Okay, for today's subject.
No.
Okay, so no question.